All right. Good.
Okay. We're kind of hitting just a couple topics now. So we're bouncing around a little bit, focusing a lot on using resources to solve those. So we're going to hit a topic today, and then, let's see, no school Monday. So Tuesday, we'll do one last topic. Then we'll do review over all the quadratic stuff next week, test next Friday, and after that, it's EOC review for here on out. So, that's exciting. I have a great proposition for you guys when it comes time to the EOC too. So.
Come in.
Yeah. Sure. So the last or next little thing we need to talk about is just the difference among different functions. So we have seen linear functions before, and when we say linear, what does that mean? It's a straight line.
Yeah.
And then we saw quadratics, and what were quadratics?
Not straight.
Not straight. What did their graph look like?
Curve.
Curved, and it was like the U, the parabola, right?
Yes.
So linears were lines, just straight line. Quadratics, those are like your U, your parabola. Then there's one other type, which is called an exponential. So today, we're not going to write equations for them or anything. We are just going to practice how can I look at either a graph or an equation or a table and decide which one is which. Excited. So, linear, your equation, something like y equals mx plus b. So the key to that, your equation, it just has an x to the first. Remember, m was our slope. So if the slope was positive, what was true about our line?
It will go up.
And if our slope is negative,
It goes down.
then the line's going down. All right. Quadratics, that's what we just got done doing. Those had an x squared in them. And so we know if a was positive, so for an ax squared, what did our graph look like? If it were positive, it were facing up, and if it were negative, it went down.
So smiley face.
Yes. So something like that. Okay, the last ones. We haven't really seen these before. The exponential are y equals a times b to the x power. So the thing that makes it the exponential is the exponent is your variable. A and b here just represent numbers. When you look at these, if your b, the number being raised to a power, is greater than 1. So if you, here, let's pull up Desmos real quick. That worked really well. Okay, so let's see what this graph looks like. If I did something like y equals 2 to the x power, it looks like this. If I said y equals 5 to the x, looks like this. If I said y equals 2 times 7 to the x. All of these are kind of looking the same, right? They're just going up. They flatten out. Do they ever go past the 0 here? Okay. These are called exponential growth. And the thing that's making them grow is the base, the number we're taking to a power, is bigger than 1. So on this, if our b is greater than 1, then that means the graph is rising, it's growing, we call it exponential growth. Now let's see what happens if we do a number between 0 and 1. Okay, I'm not doing negatives, that kind of does something different. But if I said, like, y equals 0.4 to the x, or y equals 0.9 to the x, or y equals 2/3 to the x power. What's different about these? They're going down. So if the base is between 0 and 1, then that's what is called exponential decay, because it's getting less over time and it's falling. All right, so those are the three main types we're talking about. Linear, which we know can positive or negative slope, quadratic, and exponential. So first thing we're going to do, if we just look at an equation, can we decide if it's linear, quadratic, or exponential growth or decay? So number 1, what would this be? Y equals 4x minus 7.
Decay.
Well, growth and decay happens if it's exponential, when the variable is an exponent. This is just an x to its first. This is just y equals mx plus b. That's linear. But when we get to number 2, look, now where is the x at? It's in the
top.
exponent. Okay. If you're not sure if it's growth or decay, what could you do?
Put it in the thing.
Yeah, put it in Desmos. If you do y equals 5 to the x, it's exponential because the variable is the exponent. Is it growing or decaying?
Growing.
Yep. So this is exponential growth. Question. What about number 3? Quadratic. We have an x squared. Number 4. This is exponential because the variable is the exponent. If you don't know if it's growth or decay, what could you do? Graph it. 2 times 1/4 to the x. Because the 1/4 is smaller than 1, when you graph it, it is falling. So it's decay. Number 5.
How do you get the time on it? Just a dot? Or
If you do, you're welcome. All right, number 5 is written in factored form, but if we multiply this out, what would we end up with? We would end up with quadratic. What if you weren't sure? How could you check? Yeah, you can either multiply it all out or type it into Desmos, and we know if it's a quadratic, what should our graph look like? The U. Yep, either up or down. So this one's quadratic. What's 6 going to be?
Exponential. Oh.
Yeah, it's exponential if the x is in the exponent. If it's just multiplied, that's linear. If you're not sure, how can you check?
Probably quadratic.
You could always graph them, right? I want you guys to take a few minutes and try the next ones. Just decide which type it is. All right, what's number 7?
Exponential decay.
No, that's growth.
How's it growth? Because
Because
my
the
line
one
goes-
on top is
Then
bigger
why?
than the one on
my
bottom.
line goes down.
You're so
It does.
down.
Yes.
Oh, because you typed 1/3 and it's
Oh.
The one on top is bigger than the one on bottom. Then it is growth. No, I just guessed.
Divided by-
I don't understand one half.
Okay, number 8, y equals 6. We don't even see an x in there.
Linear.
Linear, what kind of line is that?
It's
Straight.
Up.
Oh god.
Most lines are? Yeah, horizontal.
No.
0. All right, what about 9?
I don't know because there's a 2.
Oh,
There's
that
a
gotta
two.
be linear.
It's
Again.
quadratic, right?
Quadratic. If,
How?
I put it in this.
did you do the square on it?
Hey, I guess.
Oh, no, we're on number
Right,
8.
right, you don't like that.
I was holding it like this.
Why go sucker look? Why is it Nick?
It was for kids and shit. No, I normally write like
What?
this.
Right off.
All right, number 10. This one is a trick question because it's y divided by x. if we had to get this to be y equals, what would I need to do with that x? Times. The opposite of dividing is multiplying. If I took everything times x, we get x squared plus x. So this is quadratic. So it's because it was y divided by x. We had to think about multiplying that over.
Exponential.
All right. Number 11,
Exponential growth.
exponential growth. And number 12. Linear. There's nothing to the second power. Okay, let's do the same thing by looking at graphs. What would 13 be?
Exponential.
What's 14?
Linear.
Well, y'all give me a chance to answer.
Would that one have a positive or negative slope?
Negative.
Oh, you got that?
15
Quadratic.
I already said it.
Nobody was being.
I said it before anyone else did.
is the A
Negative.
positive or okay, trick question. 16.
Exponential.
Does it, is it a parabola?
I'm fine.
Oh.
Is it a line? No.
Zero.
Does it follow that other pattern?
No.
This one's none of them. 17.
Linear. Positive.
Linear positive slope. Good.
Exponential.
18 is
Okay.
exponential decay.
Be quiet.
Okay.
Because I was gonna.
So from the graphs, it's not too bad. From the equations, even if you get confused, you could get a graph and find it. The last thing, we're going to decide
Dude, I'm so hot.
how to tell. Is it? I mean,
Hot in here.
Let's get y'all's breath. Like, what's on there?
there you go. Turned on the air for you. Okay. The final thing, looking from tables. So we have some options. You could get a piece of paper and start plotting all these points and look at what the graph does. So plot these points and see, is it making a line, is it making a U, what's it going to do? We can also look at patterns. So if we have a table of values, if there's a constant change in the x, and the pattern of y will tell us what's going on. So if I look, all my x's are going up the same amount. Okay, so my x's here went up 3. What's happening to my y's? How do I get from -5 to -6?
It's going up by 1.
Okay, we add 1. From -6 to -7, we add 1. -7, -8, we add 1. -8 to -9, add 1. If you're adding or subtracting the same number every time, that's linear. So we can look at the y's. If we're either adding or subtracting the same number every single time, that's a linear function. Now let's look at a quadratic. So my x's, make sure they're all increasing by 1, so that's okay. How do I get from -3 to 5?
2.
That's a lot.
2.
3.
From, that's
5.
from positive 3 to 5.
Oh,
Right,
wait.
3. So it'd be 8. To get from 5 to 9, 4. 9 to 9,
0.
and 9 to 5,
It's
we
-4.
subtracted 4. Okay. Is that linear? No, because I didn't add the same thing every time. So now let's do it again. If we go from +8 to +4, we have to subtract 4. To go from +4 to 0, we subtract 4. From 0 to -4, we subtract 4. So linear, we see the pattern the first time. Quadratic, it's the second difference. That's the same. So exponential, we have to be multiplying by the same thing or dividing by the same thing every time. So to get from 2 to 6, what do we do? Times 3. From 6 to 18, times 3. 18 to 54. 54 to 162, times 3. So exponential, you are multiplying or dividing the same thing every time. Okay, so those are the three options. If that doesn't happen, then it's none. So, little summary here, if there's common difference in the first y values, that's linear. Second y values, that's quadratic. Ratio means multiplying, then it's exponential. Alright, so let's try some of these. So first, just verified my x's. We are increasing the same amount every time, so that's okay. How do we get from -4 to -6?
I do
From -6 to -8.
2.
From -8 to -10 plus 2. So what does this mean? Linear. Oh, it's not adding 2, it's subtracting 2, isn't
That's
it?
what I was thinking too.
Don't tell me why. You agree.
I didn't say.
Okay, let's look at this one. 135 to 45. That's a little harder. Am I
I thought
just
about 3.
okay?
Oh.
Matthew's on top of
Matthew?
that.
Matthew's on his stop.
Let's see. If you do 45 divided by 3, do you get 15? Do you get if you do 15 divided by 3, do you get 5? So what does this mean?
It's quadratic or exponential.
Okay, growth decay because it's getting smaller.
Well, if you're looking at it from the other way.
True, but you have to look as your x's are getting bigger. What are your y's doing? Right, 21. So what am I doing to get from -5 to 25? You can multiply by a -5. Would that get me from -25 to 59? No, so it's not the multiplying. Can we add? If we add
Times 5. Oh.
30. Okay. We're at 25. What do we have to add to get 59?
Oh no.
From 59 to 97.
38.
Okay, so it's definitely not linear. Those aren't the same. If it's quadratic, it's the second difference. How do you get from 30 to 34? From 34 to 38. Those are the same. So quadratic. Okay, 3 times 4 is 12. 12 times 4 is 48. 48 times 4 is 192. So this would be exponential, and it's growth because it's getting larger. Are we okay with these guys?
Okay.
All right.